Today we are checking for prime numbers, we are breaking camelCase, we are reversing and rotating chunks of numbers in a string, we are creating a strange, weird string casing, and then we are comparing and weighting weights. Hello world, and this is Versus Codewars. We begin today with the warm-up segment, a series of easier katas in order to prepare for the more difficult katas later in the episode. Starting with a needle in the haystack. We are given an array of strings and other random junk, and the goal of this kata is to find the index of the array of the first instance of the string that says needle. And we have to return a string that says found the needle at position plus the index it found the needle at in the array. Let's go ahead and get started with this one here. Our function signature looks like const find needle, and our array here will be called Haystack. And what we'll go ahead and do is we're going to look for the index of the first instance of the string that says needle. And we can do that by using the array object's findIndex method. We're going to create a constant here called needle index, and what we're going to do is haystack.findIndex. Now we'll pass in the element and the index into its predicate function here. Well, actually we don't need that here. And what we'll go ahead and do is we will return true if element is equal to needle. And then what we'll go ahead and do here, we'll return a template string that says found the needle at position. And then in our template here, we'll put in needle index. All right, let's go ahead and punch this into Codewars and see what that looks like here. And we are good on that. Our next warm-up kata, we are calculating the average value of the elements in an array. Let's go ahead and give this a try here. We're going to do const find underscore average. We're going to pass in our array of numbers here. First, we need to check to see if the length of this array is 0. And if it is, we will just return 0. Otherwise, what we'll go ahead and do is, array.reduce. We're going to run this array through the reduce method here. In the predicate function, we'll have our accumulator and our value. We're going to add that value to the accumulator. We're going to have an initial accumulator of 0. We're going to take that resulting number and divide it by the length of the array. In so doing, we get the average value of the numbers in the array. Let's go ahead and punch this into Codewars and see what that looks like. And we are good on that. Our next warm-up kata, we are given a list of digits, and we have to return the smallest number that can be formed from these digits using the digits only once, ignoring any duplicates. Alright. As you can see, we have an array of numbers here, and we have to return the smallest number that can be formed using only one instance of those numbers given. Alright, let's go ahead and give this a try here. Const min value, and we have, I think a better term for this parameter would be digits. Alright. What we are going to go ahead and do is we are going to convert this digits array into a set. Now in JavaScript, the set object only allows one single instance of its elements. For example, you can't have more than one instance of the number 1 in a set, unlike what you could do with a regular array. So what we'll go ahead and do is we're going to create a new set called digit set, and we're going to pass in the digits array into our constructor here. Let's go ahead and console.log that and see what that looks like here. And what we're going to go ahead and do is console.log min value, and we're going to pass in an array with the aforementioned 1, 3, and 1. Let's punch this in a node and see what that looks like here. Node warmup minimum. And we have our set with a 1 and a 3. Alright, what we're going to go ahead and do with that is... what we're going to go ahead and do with that is we're going to spread the elements of that set out into a new array. We're going to sort it into ascending order. And then what we'll go ahead and do is we're going to join that together into a string using a blank space separator. And we're going to take all of that and encapsulate it into a call to parse int. Alright, let's punch that in the node and see what that looks like. And we get to the number 13. Let's try another test case here. Here we have an array of the digits 5, 7, 5, 9, and 7. Passing that into our Kata solution, we get the number 579. And how about this larger looking array here? 1, 9, 3, 1, 7, 4, 6, 6, and 7. And we get 134,679 as the return value. Alright, let's go ahead and punch this into Codewars and see what this looks like. And we are good on that. Our next warm-up kata, we are looking for the factorial of a given non-negative integer. For example, the factorial of 5, which would be denoted as 5 exclamation point, would be 5 times 4 times 3 times 2 times 1, which would be 120. By convention, the value of 0 factorial is 1. Let's go ahead and give this one a try here. What we need to do, if the input is below 0 or above 12, we need to throw an exception. Alright, let's go ahead and give this a try here. Const factorial, and we have our number input here. We need to handle the edge case of numbers below 0 and above 12 first. If number is less than 0 or number is greater than 12, throw new range error in JavaScript. I think we'll call the exception number out of range. And what we'll go ahead and do here, what we need to do is, I think we do for let index equals number. Number is greater than or equal to 0. Or rather, number is greater than 0. And minus index. And this actually needs to be index here. Alright, we're going to go ahead and keep track of our result here. And we do, before we continue, we do have one other edge case to work on here. Else if number is equal to 0, we just return 1. Anyway, we have our result here. We're going to go ahead and do... Oh, okay. We start with our number here. And then we start the index out at the number -1. So what we'll go ahead and do here is result times equals index. And then we will go ahead and return that index, or rather our result right here. Let's go ahead and test this out here. Console.log factorial, and we will pass in, for example, 5. Feed that node and see what that looks like here. And we get 120. Let's try 12. Got a pretty big number here. About 14. Let's force an exception here. And we do have a range error, number out of range. Passing in 0. We get 1. Alright, let's go ahead and punch this into Codewars and see what this looks like. And we are good on that. Finally, we are counting the divisors of a number. Given a positive integer, we have to count the number of divisors and return that number. Random tests in this case go up to 500,000. Let's go ahead and give this a try here. Const get divisors count. And we have our number as a parameter here. Okay. What we need to do first, let's determine if the number given is even or odd. Const is even, and we'll set it to true if the remainder of number divided by 2 is 0. And if it is even, we'll set an endpoint. Depending on if the number is even, we'll go ahead and divide the number by 3. Number divided by 3. Otherwise, or 2 rather. Otherwise, math.round number divided by 3. And what we'll go ahead and do here is for let index equal 1. Index is less than or equal to endpoint plus index. Alright, we're going to go ahead and keep track of our divisor count here. If the remainder of number divided by the index is equal to 0, we will increment the divisor count. Alright, and we will go ahead and return that right here. Alright, let's go ahead and test this out here. Console.log get divisor count. Let's pass in 500,000 here. Start it right at the top here. Node warm-up divisors. And we get 41 distinct divisors here. Let's try some of the other tests here. 30. I expect to see 8, and we do not. Let's try running a math.ceiling here, actually. Okay. Alright, where are we going wrong here? 1, 2. 30 is so. Oh. Okay. Oh, we actually need to include the top-end divisor itself. Okay, what we'll go ahead and do is set divisor counter to 1. Or rather, to 2, because we know that 1 is a divisor of any number. So we'll start the index here at 2. And we do have 8 divisors for the number 30. Let's try 12. We have 6 divisors for 12. There should be 5 divisors for the number 2. And 3 divisors for the number 4. And yep, let's try the number 54 here. I expect to see 8 divisors here, and we do. Alright, let's go ahead and punch this into Codewars here and see what that looks like. By the way, if this were to return 2, if this function here were to return 2, we would know that this number is a prime number. Alright, let's go ahead and run the test here. And we have a problem. What's going on? Expected 2 to equal 1. Alright, what is the number we are passing in here? Console.log number. Alright, we are passing in 1. Okay, that is an edge case right here. So what we'll go ahead and do up here. Oops. Keyboard work here. If number is equal to 1, we will return 1. Alright, let's go ahead and reflect that in a kata here. Alright, let's go ahead and submit this. And we are good. That concludes today's warm-up segment. I will see you in the next kata. Given a number, the goal of this kata is to check to see if that natural number is a prime number. Prime numbers are natural numbers greater than 1 with exactly 2 divisors, itself and 1. Alright, let's go ahead and get started with this. We know that numbers 1 or less cannot be prime. So, if number is less than or equal to 1, we return false. We also know that the number 2 is the only even prime number. So if number is equal to 2, we go ahead and return true. Now, what we can go ahead and do is we can go ahead and iterate from 2 all the way to, I think it's the square root of our number. And for each iteration of this loop, we check to see if number is divisible by our index here. And we do that by checking to see if the remainder of number divided by index is equal to 0. And if it is, we go ahead and return false because we know now that this is not a prime number. If we reach the end of this loop without finding a divisor here, we can just go ahead and return true because we know that the only 2 divisors of this number are itself and 1. Let's go ahead and test this out here. Let's have a look at some of these tests here. 5099 console.log is prime 5099. Let's go ahead and punch this in a node and see what that looks like here. Node is prime. I is not defined. ++ index. And we do get true here because 5099 is a prime number. So go ahead and run math.pow 2 to the power of 31. Let's see how performant that is. And we get false for that one, which tells us this is pretty performant. So what we're going ahead and doing here, first we're checking to see if number is less than or equal to 1. Because prime numbers have to have exactly 2 divisors. 1 has only 1 divisor here, so this cannot be a prime number. 0 cannot be a prime number, and negative numbers cannot be prime numbers as well. So we go ahead and return false in that case. 2 is the only even prime number out there, so we check to see explicitly if number is equal to 2, in which case we return true. Now, in this for loop here, we start an index at 2, and we iterate all the way to the square root of this number here. And for each iteration of the loop, we find the remainder of number divided by index. And if it comes out to 0, that means we have a third divisor here, in which case this number cannot be prime. We return false here. If we reach the end of this loop without finding another divisor, we go ahead and return true, because we know the number is prime. Let's go ahead and punch this into Codewars and see what this looks like here. Run the tests. And we are good. So why is it that we loop up to the square root of the number that we pass into the Kata solution here, rather than the number itself or number divided by 2? Well, according to an answer on Stack Overflow by Sven Marnech, if a number n is not a prime, then it can be factored into two factors, a and b. A and b cannot both be greater than the square root of n, because if it were, the product of a times b would be greater than n itself. As such, at least one of the factors must be smaller than the square root of n. And if we can't find any factors less than or equal to the square root of n, then n must be a prime number. I will link this answer on Stack Overflow in the description box below if you would like to learn more about this. Given a camel-cased string, the goal of this kata is to break up the camel casing by placing a space before each capital letter in the string. The resulting string will have a space between the 5, 4, 3, 2, 1. Given a camel-cased string, the goal of this kata is to break up the camel casing by placing a space before each capital letter. The resulting string will have a space between the words. Let's go ahead and give this a try here. I think we will use a regular expression for this one. Const capital RegExp. And what we'll do here, we will look for any instance of letter capital A through capital Z. Alright, what we will go ahead and do here, we're going to return str.replace. We're going to replace all instances of that capital any match that this regular expression makes with a string. And we're going to have a replacer method here, replacer function here. We're going to pass match into it. And what we'll go ahead and do, we're going to return a space followed by that match. Alright, let's go ahead and test this out here. Console.log solution. We're going to pass in camel casing. Let's speed this into Node and see what that looks like here. Node break camel case, and we have our camel casing broken here. Note the space before the capital C in casing. Let's try another string. Identifier. What about a blank string? How about this one? Hello world. And this is versus Codewars. And that is not what we wanted to see here. And I think I know why. We need to have this global flag at the end of our regular expression here. And yep, this is the desired result here. Let's go ahead and punch this into Codewars and see what that looks like here. And we are good. Here is another way to implement this kata solution without the use of a replacer function in the string object's replace method. Pay mind to the code snippet you see below me here and pay note to the A through Z in our regular expression. Note that this one is encapsulated further in parentheses. That indicates a capture group in regular expressions. Whenever a match is turned up in our string to this regular expression, that match will be captured. Now, pay mind to the string you see in the second parameter of the replace method here, and note the $1 here. That basically tells the replace method we want to replace this $1 here with whatever was captured in the first capture group of the regular expression that we passed in, of which there is only one, that A through Z. Now, that $1 will be replaced with whatever was matched in that capture group. Given a string of digits, which will be sliced into substrings, henceforth after referred to as chunks, of exactly a given number of digits, the goal of this kata is to do the following to each chunk. If the sum of the cubes of each of that chunk's digits is divisible by 2, we reverse the digits of that chunk. Otherwise, we rotate the chunk by moving it left by 1 position, such that the position of the first digit of the chunk is moved to be the last position. The last chunk is ignored if its size is less than the chunk size given. The modified chunks are then joined together into the string to be returned. Alright, let's go ahead and give this a try here. First, we need to split the string into its individual chunks here. And what I think we'll do is, we'll do const chunks. We'll send that to an empty array. Alright, we need to do some checks here first before we get started. If the size is less than or equal to 0, the string is empty, or the size is greater than the length of our string, we just go ahead and return a blank string. Now, we have this array of chunks here. We set it initially to an empty array. What we'll go ahead and do is, we're going to do a little for loop here. Let index equals 0. Index, I think, is less than the length of our string. And for the step here, we do index plus equals size. And what we will go ahead and do here is, I think it's chunks, not push. We're going to run the string through the slice method here. Slice, we slice starting at index, and then we go to index plus size. Alright, let's go ahead and feed this into Node and see what that looks like here. I'm just going to go ahead and return our chunks for now. We're going to do console.log rev.rat. I'm going to pass in 1, 2, 3, 4, 5, 6, 9, 8, 7, 6, 5, 4. And then we'll pass in the 6 for our chunk size here. Let's feed this in a Node and see what that looks like here. Clear that here. Node, reverse, or rotate. And we have our 2 chunks here. 1, 2, 3, 4, 5, 6, and 9, 8, 7, 6, 5, 4. Let's go ahead and try another little chunk here. Another string of digits here, and try splitting this into chunks of 4 digits. And we have our 5630, 0065, 5734, 4964, and then we have the smaller chunk of 85. Alright, we will need to deal with that here because for the sake of this Kata solution, if a chunk results that is less than the size given, we go ahead and ignore that chunk. Alright, what we will go ahead and do is, we're going to run this, through the reduce method here. That is going to be how we produce our string here. We're going to call this rev.rat string, and what we're going to go ahead and do is, we're going to go ahead and take our chunks array, we're going to run that through the reduce method. Our accumulator will be our string. Our accumulator is going to be our string. We're going to have our chunk here as well. Our initial accumulator here is going to be a blank string. And what we're going to go ahead and do is, first we need to check the size of the chunk. If the size of the chunk is less than the size given, we just go ahead and return the accumulator plus the chunk unmodified. Now, what we'll go ahead and do is, we need to split the chunk into its individual characters and then convert them into integers. So, what we'll go ahead and do is const cubed. We need to take those digits, cube them, and then add them together. So what we'll go ahead and do is we'll take the chunk, split it into its individual characters, convert them into integers, parse int char, And then we'll take that and run that through the reduce method. I think the better name for this constant would be sum of cubes. Anyway, what we have here is, now in the body of the reduce method's predicate function here, we'll have another accumulator and our value here. And what we'll do is we're going to take our accumulator and add value to the power of 3. So what we do here, we're taking the chunk, we're splitting it into its individual characters, we're converting each of those characters into integers. We're running that resulting array through another call of the reduce method here. And in this reduce method's predicate function, we have our accumulator here, which will initially be set to 0. And our current digit integer here. We take the accumulator here, and then we add to it the value that we have here raised to the power of 3, or in other words, cubed. Now, what we need to do here is we need to check to see if this sum of cubes is divisible by 2. And we do that by taking this sum of cubes, and we get the remainder of that divided by 2. And if it comes out to 0, then we know that this sum of cubes is divisible by 2, in which case, according to the Kata instructions, we need to reverse this chunk. And we do that by, I think it might be a better idea if I place this resulting array from the split method here in its own array here. Chunk.split into its individual characters, and what we're going to go ahead and do is do that digits array right here. Alright, what we're going to go ahead and do anyway, because we know this is divisible by 2, we go ahead and reverse that. So return accumulator, and we do digits array, not reverse, not join, with a blank string separator. Now, otherwise, if this sum of cubes is not divisible by 2, we need to rotate it. We need to move the chunk left by 1 position, such that the digit that was at the first position of the chunk is now at the last. So what we'll go ahead and do is return our accumulator. I think it's digits array at -1, and then digits array. Oh, wait a minute. Okay, I have an idea. Digits array dot pop, because if we pop an element from the end of the array, this will return it. And then I think what we do here is digits array. Okay, I have another idea that might make this a little more readable. First, we'll go ahead and get the last digit here, and we're going to set that to digits array dot pop. And then what we'll go ahead and do is we'll have our template string with the accumulator, our last digit, and then the remaining digits of the digits array. No. X actually needs to be the first digit. My bad. Let's fix that up here. We actually need to shift here, pop the first element from the beginning of the array and return it, and we set it right here. No. Okay, let's alright, let's step back here for a second. We need to shift that chunk left by 1 position. So yeah, the first element needs to be the last. So what we'll go ahead and do is we'll take that first digit and we'll set it to the return value of digits array.shift. This will pop the first element from the beginning of the array and return it. And then what we'll go ahead and do from there, we'll return a template string, our accumulator, what's left of the digits array, joined together with a blank string, and then our first digit. Alright, let's go ahead and test this out here and see what that looks like. Because we need to return that. Okay. Yeah, we can go ahead and return our rev.rot string here. Alright. And we have the sequence here. 0365. Oh, wait a minute. Ignore the last chunk of its size is less than SZ. Okay. We just go ahead and ignore that last chunk if it's smaller than the chunk size. Alright, anyway, we have 0365, 0650, 7345, 6944 as the return string, which is the desired result. Let's go ahead and feed this into Codewars and see what this looks like here. And we are good. I will have to say this was quite the fun one here. Not really much to say about this one. However, the caveat to using array methods like pop or shift to remove elements from the array or push and unshift to add elements to the array is that these methods modify the array. Another way to implement the chunk rotating functionality in this Kata solution without modifying the array would be to do this. Take the array or string and use the slice method to slice starting at index 1. That way you get all but the first element or character in the array or string. And then concatenate to the end of that the first element or character of the array or string. That way you have that functionality implemented without modifying any of the arrays. Given a string, the goal of this kata is to convert that string into a weird string case such that all even index characters in each word are uppercase and all odd index characters in each word are lowercase. Let's go ahead and give this one a try here. First, we'll go ahead and split the string into its individual words using a space separator. And what we'll go ahead and do is we're going to run this through the map method. We're going to pass in our word into the predicate function. And what this will do is we're going to split that word into its individual characters. We're going to go ahead and map each character. We're going to need the index in our predicate function here. Alright, we're going to go ahead and check to see if that index is an even index. And if it is, we're going to go ahead and do char.to uppercase. Otherwise, char.to lowercase. Then we're going to join that word back together with a blank string, and we're going to go ahead and join that resulting words array back together with the space. Alright, so what's going on here is we take the string, we split it into its individual words with a space separator using the split method. We take that resulting array and run that through the map method. In its predicate function, we take the word as a parameter here, and what we do to that word, we split it into its individual characters with a blank string separator using, again, the split method. We run that as resulting array through the map method, And in this predicate function, we take the character being worked on and the index of that character. Now, we check to see if the index is divisible by 2, if it's even. And if it is, we return that character converted to uppercase. Otherwise, we return the word converted to lowercase. We then take that resulting array of characters and join that back together with a blank string separator. Now, we take the resulting words array produced by the map method up here, and we join that together with a space separator right here. Let's go ahead and test this out here. Console.log to weird case. And we're going to pass in weird string case here as the word that's going to be converted. Let's go ahead and feed this in a node and see what that looks like. And we have weird string case with each other character in each word uppercase and the other characters lowercase. And that is what we want to see here. Let's go ahead and feed this in a node or Codewars here and see what that looks like. And we are good. Given a string containing numbers representing the weight of the members of a weight loss club, the goal of this kata is to sort those weights out in the ascending order of the sum of their digits. Different weights with the same digit sums will be sorted by their strings, also in ascending order. Let's go ahead and get started with this here. First, now our weights are being contained in strings, so we'll go ahead and split that into its individual weights. Const weights. Weights array. We're going to go ahead and split our weights into its individual weights using a space separator. And actually what we'll go ahead and do, we're going to go ahead and return weights array. And we're going to run that through the sort method here. In our predicate function, we have our A and B here. And what we're going to go ahead and do inside this predicate function here, we're going to go ahead and we're going to have our A sum, A digits sum, and we're going to set that equal to A dot split. We're going to split that weight into its individual digits here. And we're going to go ahead and run that through the reduce method here. We have our accumulator and our digit. And what we're going to do is we're going to add the parsed integer of our digit to our accumulator here. And we're going to repeat this with the digits in B as well. Now, at the end here, we're going to compare the sums of our digits here. And if A digit's sum is equal to B digit's sum, we're going to handle that very shortly. First, we're going to handle the else case here, in which case we return A digit's sum minus B digit's sum, sorting those digits out in ascending order. Sorting the weights out, rather, in ascending order. If these two are the same sum, however, we want to sort those weights out in alphabetical order as a string. So what we'll go ahead and do is, I think we'll go ahead and return the first character of A minus the first character of B. Alright, let's go ahead and test this out here. Console.log order weight. And we're going to pass in this string right here. All right, let's feed this in a node and see what that looks like here. Node weight. Whoops. Node weight for weight. digit is not defined. Dite. I meant to say digit. Let's try that again here. We have our 100, 180, 90, 56, 65, 74, 68, 86, and 99. Let's try some of these tests down here and see how they react to our little solution here. I'm going to copy that. I'll paste that into our test right here. And we get 2,000, 103, 123, 44, 44, and 99, which is what we want to see here. Let's try this other test case right here. Copy, paste, and here we get 11, 2,000, 10,003, 22, 123, 1,234,000, 44,444,444, and 9,999, which is exactly what we want to see here. Now, before we submit this kata here, we need to join this resulting array back together with a blank, or rather a space separator. All right, let's go ahead and punch this into Codewars and see what that looks like here. Run the test again. And what's going on now?
Maybe just the strings. No, that doesn't work either.
Now, how do I sort words? I'll be right back. Okay, let me go ahead and give this a try here. If A minus, or A as a string is less than B as a string, return -1. Else if A is greater than B, return 1. Let's see what this looks like here. I think that works, right? Yeah, let's go ahead and give this a try here. Let's punch this into Codewars and see what that looks like. Yeah, let's run the tests. And we are good. I think an explanation is in order as to how the predicate function of the sort method works. The predicate function takes two arguments, A and B, both corresponding to elements in an array, and the function returns a value which dictates how those two elements will be sorted in the resulting array that is returned from the sort method. If the predicate function returns a value greater than 0, then B it will be sorted before A. If the function returns a value less than 0, then A will be sorted before B. And if the predicate function returns 0, then the original order of A and B will be retained. Now, in the sort method's predicate function body here in our Kata solution, we take the digits of two weights and we add them together, and then we compare them. If they are different, then we sort the weights in ascending order by taking the A digit sum and subtracting the B digit sum. Now, if the weights were the same thing, we take the string forms of those weights and we compare them. If A's weight came before B's weight, in alphanumeric string order, we return -1, which would cause the sort method to sort weight A before weight B. However, if the string A comes after the string B in alphanumeric string order, we return a +1, which would cause the sort method, to sort the B weight before the A weight. And that is going to do it for today's episode of Versus Codewars. If you like this episode, or you learned something new, drop a like and subscribe to my channel to see me take on more coding challenges on Codewars. As always, if you think there's anything I can do to improve on my code for the better, feel free to drop a suggestion in the comments section below. I hope you have a wonderful day, and I will see you on the next episode of Versus Codewars.